Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. I'm Miss McGuire, and today we're going to get started on Unit 2, Lesson 4. Don't forget to put your first and last name, period, and the date in the top right-hand corner of your notes. Today's topic, absolute value graph transformations. The objective for today, I will describe and graph transformations of absolute value functions. So we're going to take the graphs of absolute value functions, which we learned how to do in Unit 2, Lesson 3. We're going to learn how to transform them or move them, shift them around on the graph. All kinds of fun stuff. So the general form of absolute value functions is y equals a times the absolute value of x minus h plus k. Remember, you identify your vertex by identifying h and k from the equation. The axis of symmetry is always x equals h. A couple things I noticed when I was grading your extra practice from lesson 3 is that, remember, h has the opposite sign that it does in the equation. If h is negative in the equation, it is positive in the vertex. And when you write the axis of symmetry, make sure you always write x equals out in front of h. So you're always going to write the axis of symmetry is x equals h. All right, moving on. So the parent function of all absolute value functions is y is equal to the absolute value of h. The vertex of that function is 0, 0. The axis of symmetry is x equals 0. And then a would be 1. So how do I know all of that? Well, if you look at y is equal to the absolute value of x, technically there's a 1 out in front. So that makes a 1. Technically, we're adding a 0 because the absolute value of x plus 0 is just the absolute value of x. And then technically, we're subtracting 0 from x inside the absolute value. So I know that a is 1, h is 0, and k is 0 as well. Okay, so let's graph this thing. Remember, when you graph an absolute value function, you always graph the vertex first. Then you treat a like slope. So we're going to go, if a is 1, 1 is technically over 1. So I'm going to rise 1 and run 1. So I'm going to rise 1, run 1. Over and over and over again. Then remember, absolute value graphs are always a V shape. They're not just a straight line. With that information, if this is my vertex, this is the lowest point on the graph, the lowest or the highest point on the graph. So from there, we're going to graph our axis of symmetry, which in this case is x equals 0, which also happens to be the y-axis. So I'm going to put dashes at x equals 0. I put arrows at the end or on the top and the bottom of my axis of symmetry because it never ends. It's technically a line that extends forever. I label my axis of symmetry as x equals 0. And then I reflect my point. So I reflect this point. It's 1 away, so I put 1 away over here. 2 away from the axis of symmetry, I'm going to go 2 away from the axis of symmetry on the other side. And I start to notice that this slope is also 1, or in this case, it's -1 because it's being reflected. But I'm still going up 1 over 1, up 1 over 1, up 1 over 1, but in the opposite direction. And then I'm going to draw the rest of this V-shaped graph. And there we go. We've graphed our parent function. We're going to graph that parent function like 27 times today. So buckle up. Let's get to work. So for example 1 here, our directions are to graph each function and then describe how it transformed from the parent function. So in part A, I have y equals the negative of the absolute value of x. My vertex is still 0, 0. My axis of symmetry is x equals 0. But this time, a is a -1. So let's go ahead and graph this thing. So I'm going to graph my vertex at 0, 0. But my slope is -1. So that means I'm going to go down 1 over 1. Down 1 over 1. So I'm going to go down 1 over 1, down 1 over 1. And I have a negative slope this time. So I know that this is going to be reflected over my axis of symmetry, which is again x equals 0. So I'm going to put a dashed line for my axis of symmetry. My AOS is x equals 0. And then I'm going to reflect this line over the other side. So I'm still going to go down 1, but this time I just go to the left instead of the right. So down 1 over 1, down 1 over 1, until I have enough points to draw a decent line. And there we go. I put arrows at the end because it extends forever. All right. How does that compare then to the parent function? How did this transform? So remember, the parent function was this graph up here. It's an upward facing V shape. So if I were to put the parent function down here, it would be this upward facing V-shaped graph. Well, how does y equals the negative of the absolute value of x compare to the parent function? It got flipped over the x-axis or reflected over the x-axis. So it's reflected over the x-axis. It's just the upside down version of the parent function. All right, so now you guys are going to graph part B here without me. And then you're going to describe how it compared to the parent function's graph. Did it shift up, down, left, right? Did it flip over the x-axis? So you're going to identify the vertex, the axis of symmetry in A, and use that to help you graph. Remember, you want to end up with either an upward facing V or a flipped over downward facing V. So give it a shot. Press pause and then press play when you're ready to check your work. All right, so as you can see, I graphed the new function in purple and the parent function with my yellow highlighter. I've noticed that my vertex was at -4, -2. My axis of symmetry is x equals -4. And then my slope, or A, is 1. I put my vertex at -4. I went up 1 over 1, up 1 over 1. And then I went up 1 over 1 in the opposite direction as well. For my axis of symmetry, it's a vertical line through x equals -4. I put a dashed line, and I was sure to label it AOS, x equals -4. And what I noticed is, compared to the parent function, it just took the parent function and it looks like we shifted it down 2. It shifted down 2. And then it shifted to the left 4. It shifted left 4. All right, let's move on. So now in example 2, we're going to graph the parent function, and then we're also going to graph the new function, and then we're going to describe the transformations that occurred. So in part A, I'm going to graph the parent function in blue. The parent function starts at 0, 0 and just has a slope of 1. So I always start at 0, 0 and then go up 1 over 1. Then I do the same on the opposite side. I still go up 1 over 1, but in the other direction. All right, that's my parent function. Then I'm going to graph my new function. So my new function has a vertex at 1, 2, an axis of symmetry at x equals 1, and a slope of -1. There's a -1 out in front of the absolute value sign. So my slope is -1. So my vertex is at 1, 2. So 1, 2. And then I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And the same thing on the other side, but in the opposite direction here. Then I'm going to draw the line through these points. And then, of course, I need to graph my axis of symmetry, which is x equals 1. I'm just going to put a dashed line. Axis of symmetry, x equals 1. Okay, so how does this compare to the first, the parent function? Well, first of all, I noticed that it's upside down. So it got reflected over the x-axis. Then I also noticed that my graph shifted to the right 1, and it shifted up 2. So this vertex went to the right, and then it also went up 2. So it shifted right 1 unit, and then it also shifted up 2 units. All right, why don't you give this a shot on your own? So you're going to graph the parent function. You're going to graph the new absolute value function, and you're going to describe the transformations that took place. Pause the video and then press play when you're ready to check your work. All right, so you can see my graph. The blue V-shaped graph is the parent function. Y equals the absolute value of x. The purple one is the new function. My vertex is at -3, -2. My axis of symmetry is the vertical line at x equals -3. And I used 1/2 for my slope. So as you can see, I went up 1 over 2, up 1 over 2, etc. So how does this new function compare to the parent function? How did it transform? Well, as you can see, the vertex went down 2, it moved to the left 3, and it looks like this function is a little bit wider. It looks like we had a horizontal stretch. So I describe those transformations as a horizontal stretch by a factor of 1/2. It shifted down 2, and it shifted left 3. All right, so before we continue on, we're actually going to make ourselves a cheat sheet. So I want you to have a piece of paper. So if you weren't able to print this, you need to grab like a brand new piece of notebook paper or a new piece of graph paper. This is a cheat sheet that you're going to want to be handy for quizzes and tests to help you describe transformations of all kinds of functions. This cheat sheet is going to come in handy so much. The top half, you're going to graph the parent function of absolute value functions. In the bottom half, we're going to describe what happens when we subtract h, we add h, we add k, we subtract k, we multiply by a, we multiply by a negative. We're going to talk about how that transforms the parent function. So if you take the parent function, y equals the absolute value of h, and then go ahead and graph that real quick. What happens if you take the parent function and you subtract h in the absolute value? So you're subtracting the number in the absolute value. Well, your graph shifts to the right. What happens when you add h directly to x in the absolute value? Your graph shifts left. What happens when you add k outside of the absolute value? Your graph shifts up. What happens when you subtract k outside the absolute value? Your graph shifts down that many units. What happens when you multiply the absolute value by a number a? Well, if that number is greater than 1, so like 1.5, 2, 3, 5.5, you're going to have a horizontal shrink by a factor of a. Your graph is going to shrink horizontally. What happens if a is between 0 and 1? Like 0.5, 0.8, 0.7, 1/2, 2/3. Well, your graph does a horizontal stretch. It gets wider horizontally. And then last but not least, if you multiply your absolute value by a negative out in front, you are going to reflect over the x-axis. And that is our little cheat sheet. This cheat sheet is going to help us as we have to describe transformations of functions as we move along. All right. So let's use that cheat sheet to help us describe a bunch of transformations. Well, for the first one, y is equal to -2 times the absolute value of x minus 1 plus 5. We have a whole bunch of transformations. We're subtracting a number from x, we're adding a number outside the absolute value, we're multiplying by 2 and a negative. So we've got 4 transformations. According to my cheat sheet, that negative reflects the function over the x-axis. So my first transformation is a reflection over the x-axis. My second transformation is, well, a is 2. So 2 is, let's see, 2 is greater than 1. So I have a horizontal shrink by a factor of a. I have a horizontal shrink by a factor of 2. Then I also am subtracting 1 inside the absolute value. Subtracting a number inside the absolute value shifts the graph right that many units. So we shift right 1 unit. And then last but not least, I'm adding 5 outside of the absolute value. So I'm going to be shifting the graph. When I add outside the absolute value, I shift the graph up that many units. So I'm going to shift up 5 units. So why don't you go ahead and try B, C, and D on your own. Press pause and then press play when you're ready to check all of your work. Go for it. All right, these are the transformations I found for part B. Go ahead and check your answers. For part C, and for part D. All right, so remember now for class, you need to make sure you submit your Edpuzzle and then also go to today's folder on Schoology and get started on your extra practice. I'll see you back in class. Have a good day, guys.